Good evening, everyone. My voice is audible. Can anyone say? And my screen. Okay. So we'll start the session. So today the session will be the 7th week for the course of that biostatistic and design of experiment. And statistic part we have done with that. And now from today, maybe 2 or max 3 session will go for the design of experiment session. And today we'll start the design of experiment session. We'll discuss why do we need the design of why do we need to do the experiment, then why we have to design the experiment, then we'll discuss about some advantages, disadvantages, and then what are the types of design of experiments that is available, and then what is the process, the steps in the design of experiment, that we all discuss today, and we'll do some problem based upon the design of experiment also, that we're going to help you out to solve the your assignment problem. So let's start. So before starting to the session, last today, this will be all design of experiment. So why do we need to do the experiment? Can anyone say, it's all points are given, but still, can anyone say, why do we need to do the experiment? Let's say you are the researcher or either any master student, and someone told to do the experiment. In either way, that in terms of research also or in general also. So why do we need to do the experiment? Anyone, please? Yeah, it's a trials of drugs we can do. Okay. So, any other point? When we are doing the experiment, so we are just investigating the that is the input and output relationship. We'll be having some variable. So we'll be having some set of variable, so that we will change. That we are going to change. Corresponding to that change, what is the corresponding to this change? What is the response came according to the variable? So that's what we want to get, or if we are doing the investigation for a input-output relationship. So what is that objective? So our objective will be identify the important design variable. We'll be having too many variables when we're doing the experiment. So variable will be like not one or two. There will be that a controllable variable will be there, uncontrollable variable will be there. Some with the main factor will be there. Some will be what we can say primary factor, secondary factor, or either that we don't need the factor, but still that is available, so that we can identify the that important design variable. Then we can optimize the product and process design based upon the feedback we'll be getting when we're doing that change or investigation. So we can optimize the full process design. Okay. Then after, so that we can achieve the our best performance, that optimal performance we can achieve. if we are doing the experiment like without any design, or either we just take random experiment and then we'll do, so it will be like there's no use of doing the experiment, because we don't know that how we are going to proceed further. If you don't design the experiment, or when you don't know the anything about the experiment, the variable, what is the variable, what is the factor, what is the label. So if you do the experiments without knowing this thing, so you can't get the interpretation, or either the conclusion you can't make it. Okay, so if you say that sometime like a design experiment is a test or series, it's again a test or series of test. Like we are changing the input parameter, that we are doing the intentionally. We are doing the intentionally. Let's say I want to get the wear out, or either that wear out of metal, like wear. So we are doing the striking through the water. When we are striking the water, so water velocity can be 5 meter per second. Starting, let's say 2 meter will start, then 5, then 6, then 8. So this thing we are doing intentionally change. Based upon this change, this change, how much wear is going to come out. Wear is happening in the metal. So this is just like engineering example. If we talk about the trial, that drug trial, let's say that drug A is there. We are checking their composition, like let's say this 10% of one composition, and we'll check with the first 10%, then 11%, then 12%, then 13%. We'll check with this, and then we'll see the response, that how the effectiveness is coming. So it's like we are doing the purposefully change in the input variable of a process, so that we may observe and identify the corresponding change in the output response. So this is our main objective for the designed experiment, we'll say. So means we are going to change, or either we are going to we are doing the purposeful change in that input variable, so that we can identify, we can observe, or either we can see the, or either we can visually see that what are the corresponding change in the output response is coming. So this is the whole about the that experiment. So if you are doing through the experimentation, so first there will be many way you can go with that. So first is the trial and error method. Let's say you don't know the what can be the conclusion. Like let's say I have some certain input parameter, but we don't know how the output will look like. So for that case, what we'll do? We will be doing the hit and trial method. Based upon the hit and trial error method. Just 1 minute. Based upon the hit and trial error method, if the error will be the error is minimum, so that we are going to incorporate in our experiment, or either we will going to select incorporate in our experiment. Okay, then one factor at a time. Like let's say you have too much variables or too much factors are there. So you if you're not doing all factor at a time, so you will do you will take, okay, one factor at a time. Let's say you have in the drug itself concentration, composition, and then we can say other specific. So now we want to check the efficiency or effectiveness. So what we'll do? So this is our output response. Now first we'll check with this concentration. So we'll take one factor at a time. Second, we'll do the experiments. We'll go for the composition. Then separately we'll go for the other specific. So we'll take one factor at a time. So this is the one method. What will happen in this case, that if we take the one factor at a time, so what will happen? So we'll not get the incorporated or either interaction effect. If we're taking that each and everyone individually, what will happen? So the time process will be more, that resources will be going more, but the accuracy of that experiment or either design of experiment, it will be very less, because one factor is going to influence the other factor also. It's not the alone that any factor is going to cause that directly to the efficiency. Because of that, they will going to cumulatively they are going to give the effectiveness or efficiency of that particular drug. So, this method is also not that much accurate. So their accuracy will be the low. So then we can go for the different types of. Then we can design the experiment. So design the experiment like we have to plan. First we'll check with that first one factor at a time. Then we'll take the interaction effect. Then we'll do the factorial. Then full factorial. Then these are the things that we are going to incorporate all the factors. We are not going to left out any of the factor. Okay. So these are some approaches for the experimentation. Based upon that, our resources, based upon our need or the problem statement, we have to go with that. So why do we need that design of experiment? So this is going to reduce the time to design or develop new product and processes. So if we are going to systematically design the experiment, so they are going to reduce the time for the development of the product and then processes. Then that can be improved if we are going to design optimized way. So they're going to improve that performance of the existing processes. Okay. Then after they are going to improve the reliability and performance of the product. Then achieve if you're doing this systematically, so obviously they are going to improve the reliability and then performance of the product also. Then we can achieve the product and process robustness also. Then we can do the evaluation for the different parameter. Maybe that will be the material, maybe the design alternative. Like if we are going to design the experiment, so we can check the variance in the material. If we are changing the material, the how that our response is coming different. If we are doing some different design, so how the response is coming. So it's like in that way we can design our setting the system, like setting the component. Then we can define the tolerance also, like how much the tolerance that this particular design for the experiment that can bear it out, or either that how much the error level that can go out. So in that way, so before starting the experiment, so we'll be having thoroughly and that idea of full that parameter and all the thing, and then what is that efficiency, then product the performances, reliability, then that we all be knowing that. So that's why we need to design the experiment before starting any of the experiment. So we have to first plan it. Let's say someone is doing the research, maybe that any research you are doing. So when you are going to do the experiment work, that when you're doing the research, there will be a three way. Like one will be your numerical studies, then and that is that analytical study, then experimental study. So these other tools are we have to plan it, like what is that methodology will be there. But if you're doing the experiment, so that we need to be very careful. Like we have to take the external factor also, internal factor also. All these things based upon that we have to design the experiment in optimum way, so that we don't need to do the repetition again and again, or to avoid the noise and error and then other factor it will comes into the picture. Okay. So let's say we'll talk about some factor. What is the factor? So factor can be like input to the process. That can be a controllable and then uncontrollable. Controllable. Let's say we have a example. We say that we'll say group of people. There is one more factor. Group of people. Like that is a population. Let's say we have that sugar, or either the tea cup. That can be anything, that factor, that or either those who are that is going to affect directly the response of the what we can say experiment, like that is the response of the output they are going to directly affect. So that can be a uncontrollable or either uncontrollable. If you are doing some vibration experiment, so in that, if you are hitting with the impact hammer, so that you can control it, that it can be controlled. That uncontrollable due to the surrounding, maybe that sound noise is coming, that either the electrical noise is coming, so that can't be controllable. So that will be the uncontrollable group. So there is a factor, actually, that there is a factor that is going to directly impact the output of the response. But the level, so level is just represent the setting of each factor. So it will be like if we are setting temperature, so we'll say temperature level. If we are keeping any drug, anything in that, what we can say, that storage, so we'll say, okay, that high temperature, medium temperature, low temperature. So it's just a level. We'll say number of cups, 1 cup, 2 cup, 3 cups, like this we are. So it's a level. But about the response? Response is the output of the experiment. So if we say the case of the cake baking, so first will be the taste. Second will be the consistency. If any customer, I think they have taken, so they will say, okay, last time we have took, the taste was too good, that appearance was too good, whether it came to same or either some difference are there. So it's a consistency, maybe the taste. Then appearance of the cake can be the response also. So there are some factor. When you are going to design the experiment, so we have to know the some terminology, we have to know the some factor. We should be very aware that we should be having a very clear, crisp idea of full picture, so that we can go ahead with the experiment. Okay, so some terms will be there that is related with, directly related with the that experiment itself. But the interaction, before the interaction will be having the main factor. That factor we have already discussed. Main factor and then effect. So it will be like lonely, like one factor at a time, like one factor. When we are saying that about the interaction, so we'll be having that more than one group or more than one factor that is coming into the picture. It's like they'll be like somewhere together. Then third one, and that we have the randomization. So it's a process for that experimentation. Blocking also, it's again the process for the experimentation. Replication, we are doing just repeating the experiment with the same parameters and all the thing. So if you say sometimes the factor, if we are say if we are saying that some factor that we are saying the alone, it will be not that much effective for that particular drug and all the thing. If we are going to combine one or two, and then we if we put, so their efficiency will be high. So in that we are going to say, okay, that much there is an interaction effect will be coming into the picture. Okay, so interaction plot can be used to visualize the possible interaction between two or more factor. So it's like a, let's say we have this one, that is the one B. So let's say this one is going A bar. If I go in the B, so it's a B bar. So it means like there somewhere cutting points, it's a common point is there. So it will say that interaction effect with the interaction effect with interaction. If we have the line, both are parallel, A bar, B bar. So means this plot indicating that that A is not going to influence the B. So means there will be no interaction will be there. So we'll discuss in that coming slides also, like without the interaction, then before the interaction, or with interaction or without the interaction, how that calculation will going to change it out. Randomization. What do you mean by randomization? Randomization is a statistical tool, actually, is a methodology that to minimize the potential uncontrollable bias in the experiment by randomly assigning the material, people, or order, so that we can that experiment trial are conducted. Why do we need to do the randomization of that experiment? Why? Because we have to minimize the potential biases, uncontrollable biases. Let's say we have some box. We have some box. Let's say some four blue color, three white color, then two black colors are there. Now we have to pick it out. Like if we are doing some experiment. Okay. So if that ball are systematically designed, like systematically kept, like this is the one blue ball, two blue ball, three ball, four blue ball, then white, then two volleyball. So if we are going to take the ball, so based upon that, it will going to will take it the ball. So what will happen? So it will be obviously it will come. So it will come like that either one will be coming. So it will be biased to the any color. That will be that. And that will be biased to maybe the blue, sometimes the bias with the white, with the sometimes bias with the what we can say black. So for that, what we'll do, we are going to mix it up. We have the ball now, mixed it up. Then we'll keep so that to avoid the biases, so we have to do the what we can say randomization. Then after randomization of the run order is needed to minimize the impact of those variables outside of the experiment that we are not studying, or either sometimes what will happen, some external factor will be coming into the picture, so that to avoid that particular variable that we are not at all, that is not our interest, so that's why, so to avoid that variable, so we are doing the randomization. So this is the all about the randomization of the experiment. What about the blocking? Anyone have the idea? Blocking is a technique to increase the precision. Let's say I have some 20 or 40 set of data we have. So if we are going to do individually, so what will happen? So individual they will going to behave differently. Let's say 1, 2, 3, 4 till we have 20. If we take one is behaving positively, again positively, then negatively. So it's like sometimes we'll not get that. So what we'll do, we'll going to form a block. This is the one block. We'll take this 4 group at one, and then we'll create one block, and then we'll analyze for this one. Okay, first 4 block how they have responded, then next 4 block, then third. So it's like we are going to break the segment. It's like we are doing in the form of blocks, or either the clustering. Clustering can be done in some same type of variables. It's like just see, they just terms are there homogeneous. So based upon that, we can do the clustering, and then in order to control any potential block to block the variability. Okay, so what we are doing, like if we are going to go with that individual, so maybe we will not able to see the variability in that our experiment, so that we can club at one place, or either we can cluster it, we can classify it, and we'll keep it one place. So we'll keep, okay, this one is for one variable as a one block, second variable as a second block, third variable as a third block. Then we will do the experimental, so that our precision will be the high for the experiment. So that's why we have to be very careful when we are doing any experiment. So we have to think about the there is similarity in the experiment there or not. If it is there, so we have to cluster it, or either we have to make in terms of blocks. Then we have to go ahead with that. Next one is the replication. Anyone have the idea about the replication? Why we are doing the replication in the design of experiment? Anyone, please? Yes, please. Yeah. So replication, what we are doing running the experiment with the same configuration. We are not changing any single factor, and we are checking with that whether that is coming with the accuracy level is there or not, and with the accuracy, it's the precise way is there or not. So means, so actually this is we are checking with that, so that we can get the some sort of uh, significance is there or not. If there will be too much variance or either variabilities are there, so we will say okay, that's going to be like the change is coming, so we have to again repeat the experiment. So replication is making multiple experimental run for the each experiment combination. Let's say for one experiment, one configuration is there. One configuration is here. So for better accuracy, better precision, so we'll run or we'll going to replicate the that one experiment, and then we'll okay. So it's like validating the, in the second case we are going to validate the first experiment. Then third case we are going to validate the first experiment itself. So that this is the one approach to determine the common cause variation in the process, so that we can test the effect of statistical significance. Okay, repetition of a basic experiment without changing any factor setting allow the experimenter to estimate the experimental error. Okay, so in what will, so we are let's say initially we have designed the experiment, design of experiment we have done. So we don't know like whether that is correct or either how much the error is coming. So we'll do first set of experiment. So we will collect all the result. Now we'll do the repetition. Then we'll collect the result. Then we'll check with the error. Okay. So no, so now we'll check the error. Okay, if they are coming close together, like first and second experiments, okay, means so there will be a minimum error. So means our design of experiment, like it's a good one. If that there is a too much variabilities are there, so means okay, means there is a errors are more, so there will be noise are there. So in that, so that we can whether observed differences in the data are real or just noise. So means we can check it out like whether our experiment it coming closer to or not, or either there is some sort of error are coming, or either any other that external factor is coming into the picture. So that can be discarded through the repetition. Once we'll do the experiment, so we'll be having the large error. Like with that, let's say I have some set of result that already published one paper. So we'll be having, we are going to replicate the full experiment in at our place. So what will happen? We will be not having too much idea. So we'll start with the experiment. In the first case, what will happen? Okay, that much error difference is somewhere 30%, 20%. So now it's a very large amount of errors are there. So we will do again repetition. So it will come as 17%. Third, we'll do it came that one 15%. Then it will come to 10%. So whatever the acceptable error will be there, 5%, 4%, or 3%, or either 5%. So we are going to achieve that one, so that we can remove the noise and all these things. So now we'll come to what are the types of the design of experiment. First one is that one factorial. So it's a one factor we are saying, one factor design of experiment. Then full factorial. It will be like we are going to consider all the factor. It will be like uh, detailed. If you have, what about the fractional factorial design of experiment? Let's say we have a sometime we are doing the experiment, like we have somewhere 10 variables are there. In that 10 variables, six are six are actually more important factor. Six are actually important factor. if we are going to do for the 10, so 2 to the power 10, it will become somewhere like large number of experiment we have to do. But actually this was 6 only. So what we'll do? So we have to discard that whatever that is not there. So 10 minus 6 will do, or either 10 minus 4. So it will come like this. So it's that part we are saying the factorial one. So unnecessary, or either like that is not going to influence too much the output. So that can be done through the fractional factorial experiment. Then screening experiment. Then response surface analysis also. So as of now, like we will be dealing to that one factorial and full factorial, then fractional one. Then somewhere that first order design, then second order design, then we'll be having regression. This all content for the 8th week in the design of experiment itself. So today we'll discuss about these three. We'll solve some problems also based upon that. So when we know the types of DOE, then all these things, so we have to get to know that. So this design of experiment actually used in the chemical engineering and then bioprocesses manufacturing industries. It's like when we are doing some important aspect when reliability and precision, then efficiency is more important. So in that case, we have to design the experiment. Let's say we have to do the drug trial. So we need to check it out with that. If we have to do the aircraft design, so again we need to plan the experiment. Let's say we have a space related some problems. So we have to design in a proper way. So it's like some important aspect will be coming. So that can be used in that. So what are the steps in the DOE? First, we have to prepare the blueprint of the design. Once you are ready with all blueprint of the design, like how what are the variables, what are that factor, what are the labels, and what is the response, so you will be knowing that all. So then after, you are going to start the collection of the data. Once you collect the data, you will be doing the statistical analysis of the data based upon the number of data you have. So whatever the study we have done for the statistical, like test of significance, normality test, or either the distribution we have to do. So that's all it will be here. We have to do ANOVA testing and all these things. So that all we need to do here. Once you have done with that, so based upon that, we are going to conclude it, like conclusion. Then formulate the recommendation as a result of experiment. So there are some basic steps. We will elaborate all these steps in the coming slides also. Okay. So let's say some advantages if we talk about the design of experiment. So a design experiment is extremely helpful in discovering the key variable influencing the quality of characteristic of interest of the process. So once you will design the experiment, so it's going to discover the key variable, like the important variable, that factor that is going to influence the quality characteristic of the interest in the process. That can be anything. Quality characteristic, that can be efficiency, let's say effectiveness of the drug, or either the effectiveness of the chemical biomass, we can say. So that one we can see the which one influencing more. So we have to check with that. Okay, what are the factors are there? Like temperature factor will be there. Sometimes the weight factor will be there. Sometimes the composition factor will be there for the any chemicals and all these things. So that can be, we can discover through the like a good design experiment. And a design experiment is an approach to systematically varying the controllable change, and then we can see the that what are the how much the changes are coming in the output product parameter. By changing the input parameter, by changing the input parameter, By changing the input parameter, so we have to see that okay, how much change in coming in the output parameter. So design of experiment, actually design experiment are invaluable in the reducing the variability in the quality characteristic and determining the level of the controllable variable and then optimize the process. It's a like optimization method. So main objective for the design of experiment is like we are going to optimize the full process so that we can reduce the variability and the quality characteristic, so that and then determine the level of the controllable variable. So we can check how much the factor can be that can go maximum. Let's say 10% of this composition, let's 10% of that chemical, or 10% of that much. So that will be they will be having the range. Maybe we have to check with the range from the 5% to the 25%. We'll check the effectiveness when we're increasing that temperature, or either when we are increasing composition, whether the effectiveness is increasing all the time or not. So that we need to check it out. So that can be, we can get in the once we have we can that design the experiment carefully. So let's say we have a process is there. So we have some input will be there. That input can be anything. That will factor. Okay. So in that it will be controllable, that is the input factor, or that will be the uncontrollable. Then we will see the response. So in this process we have to know. So that process will be based upon the what are the application. If application can be a chemical, that bio, or either pharmaceutical, pharma company, maybe the engineering, maybe machines, or that can be anything. Based upon that, we have to give the input and then output. In all parameter, in all application, we'll be having some controllable factor that we can control, some uncontrollable factor that we can't control, but still we have to take care of that. So that figure can be visualized as some combination of the machines, method, and people that transform an input material into a output product. So when we're doing the design of experiment, what we're doing, so we are going to transform an input material to the output product. So the objective of the experiment may be include determining which variable are the most that is influential on the response Y. Let's say we have this one, this one X factor, Z factor is there. So which factor, maybe that can be a controllable or either uncontrollable, they're going to influence more on the Y. Okay, determining where to set the influence of X so that Y is near to the nominal requirement. So means how much that their X label should be there so that we can get the optimized output. Optimized output we can get it. Then after, so our objective will be set the influential X, so that will be a label, so that variability in the Y will be the small, like there will be a error, we can say that will be the less. Okay, then after determining where the set the influence of X, that level of X, so that effect of the uncontrollable variable Z will be the minimized. Like we can optimize this one or either level this one, so that influence of this parameter on the Y means output, it should be a less. So these are some objectives when we talk about the design of experiment. Okay, so we will see somewhere like experimental design method may be used to either in process development or process troubleshooting also. That DOE can be used for the new process development, or that can be for the troubleshooting that is already existing, so that we can improve the process performance, and then means there we can insensitive to the external source of the variability. So means we can minimize the external sources of the variability. So that experimental design method can also be very useful in the establishing the statistical control of the processes. So if we are not designing the experiment in a better way, so we will not get the data in a like controlled manner. So that we can't establish a statistical process on that. Statistical control means we are just checking the testing of the all the data came, so that we can get the better result or conclusion. Suppose that control chart is indicate that process is out of the control and the process has many controllable value input. What do you mean? Like when we are drawing any data on the control chart, so we can see that the process is out of control or not, or either process has many controllable input variable or not, so that we can visualize itself. Then experimental design method can be used to identify the influential process variable. Okay, so experimental design can also play a major role in the engineering design activity where new products are developed and then existing one going to improved. Okay, and then after that you might have heard about the Six Sigma technology, that in that manufacturing technology. So some application of the statistical experimental design in engineering design include evaluation and then comparison of design configuration. When we are doing experimental design, so we can do the evaluation, maybe the comparison of the basic design configuration. Maybe if we are changing the design from the 1 to 2, so we can do the comparison also. Then we can evaluation of the material alternative also. Then determine the key product design parameter that impact the performance. Okay, so design experiment is a powerful approach to improve the process. So let's say some of the procedure for the design of experiment. First will be the pre-experimental planning. What will be that? Recognition of statement of the problem. So when you are going to design the experiment, so we have to be very clear with the problem statement. Problem statement. Then choice of factor and then label. Then selection of the response variable. So that three things we have to know that what is our problem statement, what are the key factor that is already there, and what is the output variable is there. Then we are going to check with the which experimental design we have to go. Maybe the factorial or either full factorial or either fractional factorial or maybe the first order, the second order. Then after we have to perform the experiment. Once you are done with the experiment, you are going to do the data analysis and then conclusion and recommendation. So recognition and then statement of the problem is like it's often difficult to realize that a problem is require formally design experiment existing. So it may not be easy to develop a clear and general accepted statement of problem. You know you'll be not having the very crisp and clear idea about that design of experiment that is a problem statement, but you'll be having some picture. Actually, what we want to do, let's say someone is working on some problem. Let's say someone is working on the blockchain problem, or either any that cancer drug or any other drug. So they will not knowing that what is the exactly output, but they'll be having some picture. We have to make some drugs, or either we have to make some experiment like some that medicine, so that we are going to cure it. So we are having some picture. Based upon that, we are going to formulate the statement of the problem. Then it is absolutely essential to fully develop all idea about the. Just 1 minute. Yeah, tell me. You can come to lab. I'm taking the lecture. You can come to lab, huh?
I'm coming. I came to lab now.
Come. So we have to fully develop the idea before starting the experiment. Then we should be knowing very clear about the objective of the experiment. So this is the first step, that first we have to identify the problem statement of the problem. Then once you have done with that, so we have to identify that what are the choice of the factor and label. Then we have to check with that varied in the experiment, the ranges over which the factor is going to be varied, the specific label at which the runs will be made. Let's say we have made one drug, that is that anti-cancer drug. So now we have to do some testing. Now we have to do the experiment. So we have to check with that which group we need to take it out. We need to take, and then what are the sample size. So there are some things that we have to know that. So it's like a process knowledge is required to do this. So we have to know that what are the thing that process knowledge that should be. We have to be very clear about the whole processes. Then selection of the response variable. So so this is our output. So when you are doing anything, so we will be having some not the exact idea of the output, like it's not the exact like what will happen, but we'll be having some broad understanding that what are the output that output can be. That we don't know whether that will be coming close to that or not, but we'll be having some broad understanding. Okay, so then we have to define that one. So in selecting the response variable, the experimenter should be certain that the variable really provide the useful information about the process under the study or not. Most often, the average or standard deviation of the major characteristic will be the response variable. So that can be in terms of statistical parameter. Let's say that our output I am saying the effectiveness. Effectiveness means, let's say, so how much that average increment in the effectiveness, or either how much the standard deviation from the existing medicine they have. So there are some that we have to define in terms of that even statistical parameter itself. Then choice of experimental design. So if the three steps are done correctly, so this is going to be very easy. So in that, what we are going to consider, the choice of design involve consideration of sample size, number of replication, like how much replication we have to do, it's like how much run we have to do. Let's say that one experiment I am running, that's a biomechanics, the person is sprinting. So if we are asking the person to sprint in the first instance, will not get the data will be as much like we want. So we have to ask for the first trial, second trial, then third trial. So means it's a number of replication. Selection of suitable run order, maybe the first order, the second order, the third order, or whether or not blocking or randomization restrictions are involved. So we have to design, like we have to uh, choice of experiment, like we have to choose like which one we have to go. Maybe we have to create in terms of blocks, or either that randomization, like we have to take the random experiment, or either we have to do the replication of the experiment. So once you have done with that, which methodology you are going with that, so based upon that we are going to do performing the experiment. So means when running the experiment, so it is vital to carefully monitor the process to ensure that everything is done according to the plan. So we should not deviate from the plan itself. If we deviate, so error will be the large. So again we have to run, again we have to cross check, okay, whether how much deviations are coming when we have deviated, or either what we have planned we are going in that or not. Some necessary change we can do in between also, but not the drastic change we have to do in the experiment, running time experiment. So errors in experimental procedure at this stage will be usually destroy the experimental validity. Like if the error is coming, so means, so they are going to validity of the experiments will be null. Then after data analysis, I think we should not we should not discuss, because we have already done data analysis, that full biostatistic problem, means that distribution of the data, like normal, Poisson, and then that uniform geometric. Then we are doing testing of the data. Then we are doing non-parametric testing. So this is all this method include based upon the nature of the problem statement. We have to do the data analysis, and then it's like a statistical method should be used to analyze the data so that result and conclusion are objective rather than judgmental. So it should be a objective, not the judgmental. We should not judge. It should be objective, like our what are the output was there. If experiment has been designed correctly and it has performed according to the design, then type of statistical method required is not elaborate. Like if we have done too much, so we should be not too much worry about which method we have to apply. We will be very clear about it. We will be having very much idea about the process. We'll be having the idea of that number of variable. We'll be having the idea of number of sample. So we can just use that require the statistical method, and then we can get the better result. So for that data analysis, we have some software packages. Like if we are doing with the SPSS, we'll be having, even we can do the in the X, that is that Excel also. MATLAB is there. Origin Lab, this is also there, and even some online statistic calculator is also there. So you can use, even you can use Python and then other programming languages. So that can be done. The data analysis can be done. Once you have done the data analysis, so you will get some conclusion. Once the data have been analyzed, the experiment must draw practical conclusion about the result and recommend a course of action. Then graphical method usually are used to usually in the stage, particularly in the presenting the result to the others. So when we are making the conclusion or recommendation, so we are making the graphs, and that we are going to present in front of others, and then follow up runs and then confirmation testing should be also performed to validate the conclusion of the experiment. So actually the first to three process we will say the pre-experimental planning. Then after it is vital to possible if the experiment is to be successful. Throughout the entire process, it is important to keep the mind experimentation is important part of the learning process. That's if you are doing the experiment, so we'll be not having all the thing you'll be all knowing. What will happen? So you will be learning in the experiment itself. So very tentatively formulate the hypothesis about a system, perform the experiment to investigate the hypothesis. On the basis of the result, formulate new hypothesis and so on. So means experimentation is actually a iterative process. So it's not a one time, it's a iteration process. You will be doing many again and again to get the better result. Okay. So if we talk about the guideline of the experiment, so we have done about that. So a successful experiment requires knowledge of the important factor, the range over which the factor should be varied, and then appropriate number of the label to use, and then proper unit. Okay, so we have to be very clear about the important factor, range over which this factor should be varied, or appropriate number of the label to use, and then proper unit of the measurement for this variable. Generally, we do not know perfectly the answer to this question, but we learn throughout the experimental process. So now we'll come to our factorial experiment. Okay, so this was till now what we have discussed. We have discussed why do we need to do the experiment, then why design of experiment, like what is the approach for the experimentation. Then we have discussed the design of experiment. Then what are the advantages of the design experiment. Then we have discussed what are the method of the types of the design of experiment. Then we have discussed what are the guidelines, like that steps in the design of experiment. So now first we are going to start with the factorial experiment. So when there are several factors of interest in an experiment, factorial design should be used. Let's say I have some 4 factor. So we don't know how many the terms, that for that we have a one formula 2 to the power k. So if you have 2 to the power 4, so we have to use 16 experiment, 2, 4, 8, 16. So that 16 number of times repetition we need to do. 16 number of times we have to do the experimentation. So we will use the design matrix also for all, like 2 factor, 3 factor, and then 4 factor will do all these things. Okay, so in such design, so we have the formula like how many times we need to do the experiment. So that will be a 2 to the power k. Let's say you have two factors, 2 to the power 2. So it will be 4. 2 to the power 3, like 8. So it will go so on. So it will be like 2 to the power k times we need to do the experiment. K is factor. In such design, factor are varied together. Like sometimes the factor will be going to vary together. Specifically by factorial experiment, we mean that in each complete trial or replicate of the experiment, all possible combination of the label of the factor are investigation. Let's say you have three factors are there, A, B, C. So how we can check? First A, then B, that is alone. We can check with the AB, we can check with the BC, or we can check with the AC, or either we'll check with the ABC. So we are going to check in all possible way. All possible way we are going to check the influence of this factor on the output response. If there are two factors A and B with level factor A and B level factor B, then each replicate contain all AB possible combination. So like it's a, that we are going to do factorial process. So the effect of factor is defined as the change in the response produced by the change in the level of the factor. This is called a main effect because it refers to the primary factor in the study. So let's say we have A, B, C, and then AB, BC, AC, and then ABC. So there will be another way we got 3, 3, 6, 7, and 7. One more will become 8. So if you are going to take alone A, that influence of A or influence of B, influence of C. So that is going, we'll say main effect. It's like we are saying one factor, one time factor, one time added factor. So this will say main effect or either the primary factor. If we take about the AB, BC or AC or either ABC, so it will be a interaction effect. Okay, let's say we have some examples are there. Consider the data in this factorial design. Both the factor A and B have two labels denoted by minus plus. These two labels are called low and high respectively. So now we want to check with the what is the effect of factor A. Okay, how can we get it? Any of the idea? Let's say we have a two factor A and B. Now I want to check with that how much the influence of A is coming. So for that we have the formula. Anyone have the idea? A formula we have y bar means mean of A all positive, like what are the high terms it will coming, minus y A negative. If you want to get the B, so y bar, let's say we have this y axis now. So y bar B positive minus y B negative. So this is all about. So for this case, what we'll do? We are going to check with the y of factor of A. So what will happen? Y A plus 4 plus what is that? 40 plus 30 by 2. We can write it minus factor of A for the minus 20 plus 10 by 2. We can write it 40, 30, 50, 25 minus 15 equal to 10. So it means if we are saying, if we are going to change from the minus to positive, so it's a 10 unit difference is coming. 10 unit effect is going to come. Okay. Is it correct or either it's wrong? Can anyone say? $30 plus 40, it's a 35, sorry. 20, it will come. So we can conclude as a changing factor A factor A from low level to high level, from negative to positive. So how much change is coming? So 20. So it's a alone effect. It's not the, what we can say, without, like, it's not, we're talking about the interaction. If we talk about the B, effect of B, what will happen? So y bar positive. So this is our 20 plus 40. 20 plus 40 by 2 minus negative 1. 10 plus 30 by 2. What will happen? 30 minus 20, it will become 10. So let's say for the B, we are going to the negative to the positive. How much change coming? 10 unit change is coming. So this is all about the primary factor. Now we'll talk about the interaction effect. This is the second case. If we talk about the interaction effect, so what will happen? So fractional with and interaction at the low level of factor B, A effect is how much? At low level of factor B, A effect is how much? 10 minus 30, or either 30 minus 10, that will be 20. If we talk about at the high level of factor B, A effect will be 0 minus 20. 0 minus 0 minus 20. So it came minus 20. Since the effect of A depends on the level chosen for factor B, so we can say interaction between the A and B. Okay, so in the similar way we can get the low level of factor A. For that, how much we are getting the factor B effect? So we will 22 minus 10. Then same way, high level of factor A, what will be that? 0 minus 30, so minus 30. So that's how we can get for the fractional experiment for with the two factor, and then with interaction. With this is we are having without interaction. This is with interaction. Let's say, so this is, if you are saying, I told about when there is a no interaction, so the both lines should be the parallel. That can be anything like this, so it's not going to intersect at any point. Like there will no any interaction will be there. If you say about with the interaction, so they are going to cut at some point. So it means they are going to cut. Okay. What about the full factorial design? So this is all about the factorial experiment. Now we'll talk about the full factorial design. So let's say we have a full factorial design do require a large sample size, as the number of factor and associate level we're going to increase. Okay. So once we are doing the factorial experiment, so we'll be having some limited number of experiment. Okay, so for that case, so we are going to use full factorial design. So but for this reason, full factorial design may allow you to estimate every possible interaction. Let's say you have three factors are there, 4 factors are there, 5 factors are there, 10 factors are there. So in the full factorial designs, what will do? They are going to give clear understanding of the full picture. Means they are going to give the possibly, they are going to every possible interaction. Although you are a probability only interested in the two-factor interaction or either possibly three-factor interaction. So will two-factor we have already discussed. We'll discuss one more in terms of design for two-factor. One method we have discussed in terms of that this one, and then second will be the plus minus terms, and then three-factor design. Okay, let's say K is equal to main effect. So for our KC2 will be the two-factor interaction. KC3 will be the three-factor interaction. If we have the n-factor interaction, so it will be the formula we can use that one. And then 1k factor interaction that will. So this is for the how much number of interaction will be there. So that we can get through by this. Let's say factorial basis. So we have to design for the three factor. So this is the matrix. So we have the three factor. So 2 to the power 3. So 2 into 2 into 2. So that will be 8. Okay. So we have to write all possible. Let's say one factor is A, B, C. So in the first one, it might be the one all negative, one positive, two negative, then negative, positive, negative. So it's a all possible way you can write in a way. So 2k factorial design follow a pattern that capture every possible combination of the factor and level in the design matrix. This approach builds a model that estimates all of the main effect and then each interaction effect. So this factor actually, this is for main effect. Now the possible value will be the AB, BC and then AC, then ABC. Okay. So table 1 here is show 2k factorial design of a 3 factor with the 2 label that is coded at the low will be the minus, high will be the plus. So this is that how we can get it. Here we have to follow the rule if you are doing with the AB. So what are the rules? The multiplication of negative, like minus into minus it will become positive, or either plus into minus will become negative, negative into positive will become negative, or negative plus into plus which will become positive. So this will once we talk about that interaction effect, so that we need to follow this one. So this is about the box diagram. Cubical box. You can follow this method also, or either you can go through this also. Okay. If we talk about the properties of the 2k factorial design matrix are every column has an equal number of plus minus sign. Means this is not 9, it's a low and high setting. Okay. The sum of the product of a sign in any two column will be the 0. So means if you are going to get the summation, product of the sign in any two column will be the 0. It's we are saying that this effect we are saying calling the orthogonality property. Multiplying any column by 1 leaves that column unchanged. If you apply with the 1, obviously that is not going to change. Let's say if you have anything, you multiply with the 1 means they are not going to change anything. So it's that property we are saying the identity property. Okay, product of any two column yield a column that can be calculated the effect of another term. It's again I told A by B means AB. So we have to follow our the plus minus sign, that is the formula. So means, so every column will be having equal number of plus and minus sign. Then the sum of the product of a sign in any two column will be the 0. This product, that property we are saying the orthogonality property. Then identity property, that means if we are multiply 1 to the any column, so that is not going to change. And if your product of any two column yield a column that can be calculated the effect of another terms. Okay, so the primary properties of all factorial designs are estimate the model terms, projection and then orthogonality. So they are going to estimate all three factors. So in that we are going to projection and the orthogonality. Using a factorial design, the experiment examines all possible combinations of the each factor. Since every combination of the factor level is included in the 2k factorial design, so 2, 3 design consists of unique column for every mimic effect, every two-factor interaction, and then three-factor interaction. Let's say we have a three-factor design. So that is going to consist of all unique column. Let's say we have a B, C. So they're going to say A unique, B unique, C unique. Then possible all possible of A, B, B, C, A, C, then A, B, C all together. So larger value of K will include many more interaction from the two factor all the way up to a K factor interaction. So means when you have the large number of factor, so they are going to increase the more number of interaction. Like two factor interaction is going to be more. So let's say this is, I told this was without interaction. Okay, and if we see about this one, so this is with the effect. Let's say this is the three factor design. Three factor designs are there. Okay, so we have to run how much experiment, how many runs? So it will be the 8. So it will be the 8. Sorry, that will 8. Then we can have to choose for that, like this is that alone effect. This is the interaction effect between the two factor. This is the three factor. So this is all about the two factor interaction. And this one is a three factor interaction. Can you say any example of this? Like let's say in any drug manufacturing, what will happen? I have three A, B, C. So first I will check with the influence of A on the output. Then we'll check B influence. Then C influence. It will come on all output. Then we'll check with the AB. If we combine both AB, what is the influence of the output? If we combine BC, what is the influence? If we combine AC, what is the influence? Then in the last we are going to combine all three, what is the output it will come. Okay, so this is all about the three factor. Let's say we have a two factor A and B. So we have to run 3, 4. So this will be without interaction. If we add AB, so it will become a with interaction. Okay, so that will plus minus, minus minus, plus minus. If we talk about the AB, so plus minus, it will become minus, minus plus, minus, minus minus, plus, plus it will become. So now that's how we can check it out. So this is about, so this is that design of matrix based upon that. Now that fractional design we'll talk and then we'll do some problem based upon that. So fractional factorial design, we'll do some problem based upon this full factorial design with the three factor. We'll do problem in the last. Beforehand we'll discuss fractional factorial design. What will happen if we are talking about the full fractional design? Our common starting point when they are planning a set test. But what will happen? But as the number of factors become large, so the size of design will become very quickly. You have seen that because it's increasing in the power itself, 2 to the power k. So means size of design is going to be very large. Let's say 2 to the power 5. So we have to run 16 experiment. So it will become 1, 2, 3, 4, 5, 6 till 16. We have to define plus, minus, minus all this thing. Again we have to define all this thing. So that is how it will go. So this is for only for 4. If we go 5, then if we go 10, so what will happen? It will go more and more all the time. Okay. So if we assume each factor has 2 levels, a full factorial design with the 8 factor would require 256, 2 to the power 8. In many tests, some categorical factors have more than 2 levels, which further increase the test of size of the full factorial. It's going to be like continuously it's going to increase the design of size of the design. However, resource will be having the limited and typically impractical to conduct a test of full this size. Let's say we have a 10 numbers variable, so we can't simply run for that 1024 times. That can be a possible only 8 times we'll do, or either 16 times will we do the experiment. So we can't conduct for the all. So as the number of factors increases, 2k full factorial design grows prohibitively large. So it means there will be impossible to conduct the experiment. So in that case, fractioning the to avoid this growing of the large number of that design. So what we have to do? We have to do the fractioning of the factorial design, sacrifice the information about the sum of the interaction in favor of reducing the total number of run. So means we have to discard some of the factor or either some of the interaction, so that they are going to reduce the total number of runs. If your motivation is to identify the vital few significant factor from the trivial, so in that case we'll do the screening method. Let's say we have a 10. In the 10 itself, we have only some 5 or 6 parameters that is influencing more on the output. So what we'll do? We are going to discard the 4 other variables that is not going to affect the influence of the output. So then a fractal design is an efficient alternative to do a full factorial. So if we do the screening, so we can use the full fractional design. So this is the best practice. So why and when fractional factorial design are useful, as well as the risk associated with the using a fractional factorial design. Okay, so this is all about that I have told already, and now I will show you for the factorial design some examples also. Just 1 minute. Let's say, so if you say, let's say we have a some factors are there. So suppose there is a factor k in an experiment. All possible factors include, it will be effect of the order, effect of order 2, like main effect. If we are saying about the loan, let's say we have a b to k. So loan effect will be ab to k. Then effect of order 2, it will become jk, like 2 ab ac, then ad, then it will come to till jk. Then 3, then 4, it will become very higher. So it will become hierarchical order principle we saw. So it's going to lower order effect are more likely to be important than higher order effect. You know what they are trying to say. If we talk about we have a very large number of factors are there. So lower order, they are going to give the impact more than that of higher order effect. Let's say I have 4 variables. So any doubt is there? Any? Okay, effect of the same orders are equally likely to be important. Then affect the sparsity principle. Then affect the heredity principle. So if we come here like a fractional factorial effect, so may not have the source for the full factorial design. So what we'll do? Consider 2k design. Let's say k is equal to 7. So we have to run 120 effect. Only 7 degree of freedom for the main effect. So means 21 for the 2 factor interaction. So remaining and 10 degree of freedom are the interaction of order greater than 3. So in that case, what will happen? So we have to discard that one. So often we will consider lower order effect are important. So means we have to follow this one. Then let's say we have an example. Suppose we are going to design a car. So in that case, we have a following factor will be the engine size, number of cylinder, drag, weight, automatic versus manual, shape, and all the things. So only have a resource for conduct 2 to the power 6. So we're going to 64. But how many we have total? 9. So in that case, if we drop the 3 for a factorial design, so those factors and their interaction with other factor cannot be investigated. So that can be avoided with the aliasing. What even mean confounding? Confounding means it's like we are going to check with the all. Let's say I have 4 factor A, B, C, D. So we'll do the aliasing with the calculate the I matrix, identity matrix with the A, B, C, D. So that will be always 1. We'll show that one also. Like this, it will come here. I'll show you just 1 minute. Here, I will be the always positive. I will be the product of A, B, C, D. That what we are calling the aliasing effect, the confounding effect. So therefore, the chosen factor level the following 8 level combination. Then this one, the product of column A, B, C, D. Let's say we have the 4. So I will be the A, B, C, D. That will be equals to always 1. So that's what we are saying the defining the relation, and that's what we are saying the confounding effect. If you say about the aliasing in the 2 to the power 4 minus 1 design, like we have the 4 factor, we are discarding the 1. So what will happen? So I is equal to A, B, C, D, always 1. So A, B, C, D, A, B, B, C, then we'll collect all till C, D, then A, B, C, B, C, D, then we'll collect all this thing. So this is all about the, let's say I want to calculate the some factor of A. So we'll check with the A will be the what are the positive 1, 2, 3, 4. So what are the value will be coming that will be taking, let's say I'll for 1 we have designed 10, 10, 10, 10, 40 by 4 minus will be the minus 1, minus 1, minus 1, again this is 5, 5. So 5 plus 5 plus 5 plus by 4. So it will be 10 minus 5 is equal to 5. So how we can calculate? A is equal to y bar A positive minus y bar A negative. So we can get through this and then we can calculate. So let's do some problem. This is the problem we have. Now I want to get the effect of A, B and C. Can anyone calculate? This is this problem with the without interaction. Can anyone calculate the effect of A, B, C? I'll say the formula. A is equal to y bar A all positive minus y bar means mean, that is A negative. Just calculate and then tell me A is equal to that much, how much, then B, then C. Then I'll solve. Just 1 minute. Okay, for A, Okay. Okay, fine. For A, let's calculate 1 by 4 into this positives. We have 71 plus 65 plus 60 plus 65 minus 1 by 4. We have 45 plus 48 plus 68 plus 80. How much came total? 5. Okay, 5. And for B, similar we can, how much we will get? 3.5. C, how much will get? 11. Okay. So this was the without the interaction. Now, if you want to calculate with what you can say interaction. So let's say I'll add one more column. So can you calculate with the AB, BC, AC, and ABC? If you calculate the effect of AB, effect of BC, effect of AC, effect of ABC, please calculate. Shall I do? Like if you talk about the AB, so what will happen? AB just make one column, and BC make one column. AB will talk, so what will happen? AB minus minus plus, so it become plus. Plus minus, it will become minus. Minus plus, it will become minus. Plus plus, it will become plus. Minus minus, it will become plus. Plus minus, it will become minus. Minus plus, it will become minus. It will become plus. So now AB effect will be this positive, this positive, this positive by 4 minus this negative, this negative, this negative, this negative. So we will get the effect of AB. Similarly, calculate the BC, AC, and then ABC also. So I think this is a similar problem that is there in your assignment also. I think so. Please do it. Then we'll in 10 to 15 minutes we'll wind up the session. BC plus plus minus 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 plus plus. If you talk about the AC, minus minus plus minus 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 plus plus minus 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 plus minus plus 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 then plus minus minus then plus. So this is why we got 1 2 3 4 equal number of plus equal number of negative. For ABC, I will say I will do it here. A B C plus minus minus plus plus minus 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 plus plus minus minus plus 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 minus 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 plus 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 minus 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 plus minus plus minus minus then plus 1 2 3 4 A B C A B B C A C we got. So please calculate for the A B B C A C and A B C. It is done. AB will be getting minus 4. What about ABC? Okay. Okay. So means when increasing from 1 to 2, so it's a negative impact is coming on the output. So that's how we can conclude. I'll say for the AB, so 1 by 4, 45 plus 65, 45 plus 65, 68 plus 65, 68 plus 65. It's minus 1 by 4, 71, 48, 71, 48, 60 plus 80. It came minus 1. If we calculate about the BC, so 1 by 4, BC plus 45 plus 71. 0.5. Okay. Just 1 minute, I'll do it. Plus BC 80 plus 65. 80 plus 65. 48, 65, 68. 48, 65, 68. Then 60. 45, 48, 45 plus 48, 60 plus 65. 71, 65. 68, 80, 68, 80. Minus 16.5. If we calculate about the ABC, 1 by 4, 71, 48. 71, 48, 68 plus 65, 68 plus 65. 45, 65. Plus 65. 60, 80. So there is no doubt in this, na? So we'll go ahead with that. So the similar way, you can calculate the A, B, C, ABC, AC and BC same way. So this is the same question. If you want to calculate, so that you can keep or either just calculate how much we are getting for this one. For effect of A, effect of B, effect of C, then AB, AC, BC and ABC. So this is the last question. Please do it. Huh? No, it's a data is different. That's all. Same problem. Same as it, no? Okay. Yeah, that's all for today. If you want to do like one more the fractional factorial design will be the problem is there, that in that you can, some examples are there. If you want, then I'll keep in that slides, you can go ahead, go through that. Yeah, this I'll keep in that fractional factorial design. Yeah, it will be always same. Only thing we have to find out the alias effect, aliasing, the confounding effect. It's like we have to, it's we have to, if let's say we have a four variable, let's say we have a four variable a b c d, so I will be always a b c d, so it will be aliasing effect. Aliasing means it's the component that we are grouping all the factors. This, now we have to calculate a b b c a c, then a b c a b d. We'll calculate this one, but this will be that last one will be the I, a b c d. I'll show the PDF also. Like this, this one I. So we can get the A, B, B, C, C, and then that one. One more problem will be the one more thing here. You can see here I and this one A, B, C, D. So this is our confounding one. Remainings are, this is that primary effect. Then this is all our interaction effect. Interaction effect of order 2 till that CD. Interaction effect of order 3. So this is how we'll get it. So we know the value of A, B, C, D. So A, B will calculate minus 1 plus 1, and A, B, C will be minus 1 plus 1, and then minus 1. So minus 1. So this is how. So nothing. If we have, let's say I have 5 variable. I have the 5 variable. So that confounding will be the I is equal to A, B, C, D, E, 5. So that will be like this. Okay. Otherwise, if you go through the full PDF, and then you can get it the same way, whatever I have explained, the same way it is there. Yeah, if you want, I'll keep in that drive folder this PDF. Yeah. Actually, let's say when our number of factors getting increasing, to reduce the number of runs. So for that we are doing the aliasing. So that's usually, let's say we have some 7 variables out there, but 3 are not that much, that one, what you can say, important. So for that, what we'll do, we'll do the confounding. Then we'll 2 to the power 7 minus 3. So it will come 2 to the power 4. So we have to do the 16 experiment instead of going for the 2 to the power 7. Okay. So, and then we have to, like, a higher order effect will be the always less, because if I'm not wrong, that I have explained in the starting. What? Yeah, higher order interaction will be the always less. It will be like there will be no influence will be coming. So always the lower order going to cause the more influence. So that's why we have to avoid the higher order, that one, what you can say, interaction. We'll be taking only lower order interaction as much as possible. Often only lower order effects are important. So actually, you can, for DOE there is a separate book is the books are there. You might have went through the lectures. You have seen 1 or 2 books. So there will be a full 1 books will be there. You can go through that. It's just a brief that I am giving. That is important for the exam and then for your understanding. Well, we have to follow with statistical method. We have to apply the ANOVA and all these things to get the p value, then f value. Then we have to use the regression model also. when we have designed the experiment. It's just a designing that how much number of how much number of runs we are doing. This is up to that part we are. Then now what once we design the experiments, we have to go with the statistical test also. So that we are not dealing about as of now. What? Yeah, yeah, statistical analysis. Like I can't hear you properly. How, yeah, that's what like once you've designed the experiment, so you have to do the statistical test. So based upon the nature of the your problem statement, let's say you have a less number of sample, like less than 30, so you'll go for T test or either F test. So that will be based upon that you have to decide. Like we have done already all part like biostat that first 6 week we have done for that particular topic only. Okay. Yeah, 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 yeah. Sorry, I was not able to get your. Okay. I'll, yeah, 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 yeah. Confound. Why we are going for the confounding or other aliasing? If we are like we are just reducing the number of runs one, then now we have to reduce that. I told like we have the one thing like if we are going for the higher order, that's not going to give too much significance on that. So what will happen? So A, B, C, D or either the all factor is coming all together. So that one we are taking as a identity matrix or identity number. So that is not going to cause the effect on, but we can say our that influence. So that's why we are just clubbing it. So that that can be avoid. Remaining lower order can be taken only, not the higher order. Yeah, sure. Yeah, sure. You can ask again. Okay, fine. I'll go through and then again check. Y- Yeah, yeah, sure. Okay, thank you. Any doubt is there? And so shall we wind up the session? Okay, thank you. Thank you so much.